Hello, good afternoon, everybody. This is Nafeesh Ahmed. Today's topic of presentation is Introduction to Microprocessor and Microcontroller. These are the necessary components for any microprocessor and microcontroller. CPU, central processing unit, input output bus. Bus can be address bus and data bus, and other one is control bus. Memory, RAM and ROM, timer, interrupt, serial port and parallel port. First of all, I will define what is microprocessor. On the basis of this diagram, you can identify these are the necessary component. RAM, ROM, input output port, timer, serial communication port. These are necessary component or peripherals are connected through the data bus and address bus to the general purpose microprocessor. You can also call it CPU. And on the basis of this information, you can define microprocessor is a digital computer which does not have memory, timer, input output port, serial communication port on a single chip, and it is completely useless without these external peripheral devices, and you cannot interact with the outside. And on the other side, microcontroller can also be defined. It is a device which have all necessary components to make a computer functional on a single chip. These are the necessary components: RAM, ROM, input output port. On the basis of this diagram, you can make a clear idea about the microcontroller. All the necessary components which are required for a computer make it functional are available on a single IC. And these are the examples: Motorola 6811, Intel 8051, G-Log Z8, and PIC peripheral interface controller 16X. The most commonly used architecture is Harvard architecture. It separates the data instructions into separate memory unit, each with their own bus. Besides speeding up the data transfer rate, separating the data from the instruction permits us to implement different bus width and word size for program and data memory space. In this figure, there are two separate memories are used: program memory and data memory. And these two memories are connected to the MCU, microcontroller, through the separate buses. Now, using this architecture, you can increase the speed. And another architecture is von Neumann architecture. It can also be called as Princeton architecture. Due to the common memory is used for all the purposes, data memory as well as instruction memory, so it is have less speed. These are the common differences between the microprocessor and microcontroller. First is microprocessor is a CPU is standalone, RAM, ROM, input output, timer are separate. In microcontroller, CPU, RAM, ROM, input output and timer are all on a single chip. Second, in microprocessor, designer can decide on the amount of ROM, RAM and input output ports is required to make a computer, but in microcontroller, fixed amount of on chip ROM, RAM, input output is embedded on a single IC. Microprocessor is expensive, as you know. In microcontroller, for applications in which cost, power and space are critical, it is less expensive if I compare this microcontroller to the microprocessor. And microprocessor provide the versatility. Designer know how much amount of memory, input output ports are required for any application. And microcontroller, there is no changes can be made after it manufacturing. It is a general purpose microprocessor, and it is a single purpose control oriented, because microcontrollers are generally designed for controlling the appliances. In microprocessor, next difference is high processing power. It requires high processing power. Here in microcontroller, it requires low processing power. Next one is high power consumption by the microprocessor, but microcontroller require low power consumption. Microprocessor instruction set focus on processing intensive operation, but in microcontroller it is a bit level operations. Microprocessor are typically 30 to 64 bits, and microcontrollers are typically 8 or 16 bits. Microprocessors are typically deep pipeline, and whereas microcontroller are single cycle two stage pipeline. These are the common differences between microprocessor and microcontroller. In this slide you have seen here, these are the common example of microcontroller: 8051, microchip technology, PIC, Atmel AVR, Texas Instruments MSP 430 16-bit. It is a 16-bit microcontroller. You can calculate the respective MIPS, which one is more efficient in MIPS per milliwatt. It is the example. A microprocessor running at 600 MHz has an average CPI of 1.2 and an average power consumption of 400 milliwatt. While a microcontroller running at 12 MHz with a 2-cycle data patch has a power consumption of 224 milliwatt. On the basis of this statement, you can calculate their respective MIPS. One is more efficient in MIPS, million instructions per second. It is the second example. The previous microprocessor cost is $100, while the respective microcontroller cost is $0.96. Which one is more efficient in MIPS per dollar? These are the application related slides. Digital signal processors. These are the processors. Digital signal processors are type of microcontroller that are more specialized for a particular application. DSP represent around 20% of total MCU market. DSP are particularly well suited for real-time operation in which a data stream, video, audio, etc. is modified in some way as it is passed along to another device or the component. Most DSP are based on the Harvard architecture. DSP commonly include analog to digital conversion for their input and digital to analog conversion for their output. These are the review questions. What are the main difference between a microprocessor and microcontroller in terms of architecture, application, instruction set? Architecture. Which architecture is used? Von Neumann architecture and Princeton architecture and Harvard architecture. What are the application of microprocessor and microcontroller? Microprocessor can be used as a computer. Microcontroller, these have the application to control the appliances, and a lot of difference between the instruction set.